For rational inequalities, it's almost the exact same as polynomial inequalities. The difference is we have to take into consideration vertical asymptotes. So let's just dive straight into an example. There's some steps there, but we're just going to skip past those and just work on the example here. So example 4, x minus 1 over x squared minus 4. Notice we do have equals 0 there. So we're ready to go ahead and graph this. I will caution you, make sure you use parentheses correctly here. Put the numerator in parentheses and the denominator in parentheses. Just like so. Okay, you can see I've got the numerator and the denominator in parentheses there. And so let's look at our graph. Again, these rational inequalities, these rational functions are different than the polynomials. We have vertical asymptotes and those sorts of things that we have to work with. So looking at this, kind of identify some features here of this graph. We've got, you can see a couple of vertical asymptotes. And if you'll remember, where do we look at on the graph, on the function to know where those vertical asymptotes are? Those come from the denominator, right? Which, if we think about the zeros of that denominator, in this case we have zeros at -2 and +2, which means we have vertical asymptotes at -2 and at +2, right? And we can see that on the graph here at -2 and +2. We do have those vertical lines where the graph kind of goes crazy. So we've got that. We do have a horizontal asymptote at y equals 0, which is the x-axis. And then the only other thing we really need to know is, are there any x-intercepts? And if you look right in the middle of this graph, there appears to be a point where it crosses over. So let me calculate this x-intercept. I know over here I'm above the x-axis for that left bound. Let me go to the right until I drop down below. Okay, at that point, whoops, went a little too far. Okay, I'm below the x-axis there. So we hit enter and then enter one more time. We do have a 0 at x equal 1. Okay. Now this is all information we're going to need when we start piecing together the solution set of this inequality. So again, it's vertical asymptotes at -2 and at +2. We do have a horizontal asymptote. Oops. Meant to do at the x-axis, and then we do have a x-intercept at 1, and so kind of the shape we're dealing with here. Looks something like this. Okay. So we've collected all this information about this graph. We know where the asymptotes are, we know where the x-intercepts are. The only thing left is to determine which pieces of the graph we're really interested in. And remember, that comes from the inequality symbol greater than 0. So the parts of the graph that are above the x-axis, including any intercepts. So that would be above the x-axis, including this intercept, would be this piece. Okay, so we got this piece right here. Also this piece over here is above the x-axis. Okay, So piecing together our intervals then for this guy right here, what's the left boundary? Doesn't go any further left than that vertical asymptote at -2. And notice I don't include that endpoint at -2 because that is a vertical asymptote. So it's not going to touch that point at an x value -2. This thing dead ends at this intercept at +1. We do include that intercept. Again, that's because of the equal to part. The next piece, again, starts at that vertical asymptote at +2. And this thing, since there is a horizontal asymptote at the x-axis, it's never going to cross over below that. And so it's going to continue on to infinity, staying above the x-axis there. So that is our solution. So you can see when you're dealing with the rational inequalities, it's almost the same as the polynomials. You just have to take into consideration the asymptotes, vertical and horizontal, and know how those play into the solutions and where the graph's above and below the x-axis. Okay, 4x plus 5 over x plus 2 is greater than 3. Now, the first thing we need here is we got to have a 0 on that right-hand side. That's the first thing we look for. This needs to say greater than or equal to 0. So let's subtract that 3 off. You can just put -3, just like that. Now let's go ahead and check out the graph here. See what this looks like. So we've got 4x plus 5 over x plus 2. Again, parentheses are vitally important there for that fraction. And then we've got a -3. Yeah, -3. So here's our graph. Okay. And looks like we do have a vertical asymptote. So where is that vertical asymptote? Okay. And where does that thing come from? If you remember the denominator, right? This piece right here means I have a vertical asymptote at -2. So that's what we've got showing up right here. Any x-intercepts? Looks like I've got one right here. Let's calculate where that x-intercept is, that 0 is. So let's go to the left side below the x-intercept there, then arrow over until we're above on the right side of that x-intercept. So it looks like we're well above the x-axis at that point. And then hit enter one more time for a guess, and we get a 0 at 1. Okay, so we kind of know how this works out. We do have a horizontal asymptote, and we'll kind of see how that affects what we're doing here in just a second. So let me just sketch the picture here. We have a vertical asymptote at -2 and an x-intercept at 1. And we do have a horizontal asymptote that is just above the x-axis. Okay. And then our picture looks like this. So we have this piece here. And then we have this piece is here. Something like that, right? Yeah, not exactly, but good enough, okay? Good enough. That right piece is a little odd, but for what we're doing, that's good enough. What we need to identify is where this piece is, or where this graph is above or equal to the x-axis. So we do have an x-intercept right here that we will include because of the equal to part. And where are we above the x-axis? Well, this whole piece right here is above the x-axis, and also this entire left branch of our graph, this whole thing, is also above the x-axis. Okay, so our intervals then for this guy right here, it goes from negative infinity to the vertical asymptote at -2, stops there, and then we're going to join that with, for this guy right here, starting at +1, including that +1, and going to infinity. So that would be our solution set for that inequality. And keep in mind, these are intervals of x values, okay? We talked about way back in chapter 3 that when we specify locations on the graph, you know, where is the graph above or below the x-axis, that question of where gets answered with x values. So that's what we're describing here, is the x values where the graph is above or below the x-axis. Okay, that's the end. That's the last example here. So take a look at the homework there and put your calculator to use to find those intercepts and get those pictures of the graphs. And if you have any questions or anything, feel free to get in touch. Thanks.